The problem statement from GATE Physics 2010 reads as follows. For any set of inputs A and B, the following circuits give the same output Q except one. Which one is it? So here we have been given four combinatorial circuits, and the question says the output of three of them is the same and the output of one is different, and we need to find the circuit which has the different output. This is a multiple choice question with only one correct answer, and we'll try to find the correct one. Since this question is based on logic gates, let's have a quick overview of the logic gates first. So in the top row of the table, you can see the name of these logic gates like NOT, NAND, OR, and so on. Just below that is the algebraic expression. Note this bar denotes negation. Negation means, I will see in a bit what negation means. Then this is what is called the conjunction. You can see there is a dot here. This is also known as conjunction. This thing is also known as conjunction. On the other hand, this plus symbol is also known as disjunction. So in logic, in mathematical logic, conjunction and disjunction are like are in turn defined in more depth by something called a truth table. So for simpler understanding of the truth table, you list all the possible combination of inputs. So for instance, let's just take NOT gate. By the way, this is also known as negation. Negation means we are negating it, or sometimes this is also known as inverter. So there is only one input. So NOT gate says if the input is 0, the output will be 1. If the input is 1, the output is 0. Hence negation or inversion, right? So a truth table lists, you first list all the possible combination of inputs and then you list the outputs. That's what the truth table shows. Now let's look at this AND gate, which implements the conjunction. So here there are two inputs, you can see A and B. So A and B are like this, and the four possible combinations are 0, 0, 0, 1, 1, 0, and 1, 1. And the output is defined in such a way, by the way, this is the symbol for AND gate. Output is defined in such a way that the output, you find the output using this formula, A dot B. So 0 dot 0, 0 dot 0 will be 0. 0 dot 1, dot means multiply. So 0 times 1 is 0. Then it's 1 times 0, that will again be 0. And finally 1 times 1, it will be 1. So you can see the output will be 0, 0, 0, and finally 1. Now let's come to this OR gate, which is called the disjunction. It's denoted by the algebraic expression A plus B. This is the symbol for an OR gate. So again the inputs are 0, 0, 0, 1, 1, 0, 1, 1. And when we try to find the output, we just put a plus sign between the inputs. So 0 plus 0 will be 0, 0 plus 1 will be 1, 1 plus 0 is 1. 1 plus 1 in Boolean algebra, in 1 bits, it will be 1. This means high or high will be high. Finally, let's have a look at this XOR gate. This is also known as exclusive OR. And this is the way it expressed. The alternate way of expressing it is A B bar plus A bar B, where bar is the negation. So if you try to evaluate A B bar plus A bar B, so it will be, first term will be 0 times 0 bar plus A bar, 0 bar times 0. So it will be 0 times 1 plus 1 times 0, it will be 0. Let's do the second term also. So it will be A B bar. So A is 1 dot 0 bar plus A bar B. So 1 bar dot 0. This will be 1 dot 1 plus 0 dot 0. This will come out to be 1. Similarly, you can evaluate the other two things. By the way, this is the truth table for XOR, right? So again, truth table is nothing but you try to find the output based on the algebraic expression for all set of inputs, right? So now let's get back to the question. So this was the first, we were given 4 circuits. This is the first circuit, right? So let's just first try to evaluate what will be the output at this node. Now note that this is an XOR gate, right? So I can write the output here as AB bar plus A bar B, right? Let's try to find the output at this node now. So this node is nothing but negation of B, node B, and then so this will be B bar. Now thirdly, we have this AND gate. So AND gate would be, so I can write this node Q. So I am writing it here. So Q will be equal to the first input, which is AB bar plus A bar B times the second input, which is B bar. Straightforward. Now we simply multiplied it. So it will be A B bar times B bar plus A bar B. B bar. Now we know B bar dot B bar is nothing but B bar. So this is A B bar. These are rules of Boolean algebra. For instance, let's do this. So let's say there is some value y, okay, and so let's say it can have 0 or 1, and let's say there's some output z equal to y dot y, okay. So it will be 0 dot 0 will be 0 and 1 dot 1 will be 1. So y square will be nothing but y. So here again you can, y is b bar, so one of the b bar gets dropped, so it will be a b bar and b dot b bar. So let's again try to find the output. Let's say y again is 0 and 1, and let's say x is y times y bar. Okay, let's try to evaluate the value of x. So it will be 0 times 0 bar, it will be 0 times 1 will be 0, and then it will be 1 times 1 bar. This means 1 dot 0 equal to 0. So when you multiply the a term and its inversion, its negation, the output will always be 0. So hence this term will drop out. So we'll get q equal to ab bar. So now we have solved the first circuit. This is the second circuit. So let's first try to evaluate the value here. This is just the potential at this node will be nothing but b bar, and finally this is an AND gate. So q will be equal to the first input, which in this case is a, so a times the second input, which is b bar. So again we evaluate the output is a b bar. Let's go to the third circuit. So first we evaluate this the node, the output the voltage here. So this is nothing but negation of b, so this will be b bar. Now let's try to evaluate the potential here, the value here outside the output of this AND gate. So the output of this AND gate would be the first input, which is a, times second input, which is b bar. So the value here would be a times b bar. Now let's try to evaluate this orange circle. So one of the inputs is b bar, you can see here, and the other input is a. Note this is the wire, so a, and this is again an AND gate. So the output here at this node would be a times b bar, the first input times second input. Now let's try to evaluate the output at the output of this green the AND gate shown in green. So AND gate will be the first input, which is a b bar, times second input. Second input is this, and what is this input? This is nothing but b. So this is nothing but b, right? And finally we try to find the output of this purple OR gate. This is an OR gate, so I can write it here. OR gate will be the first input, which is a b bar. First input is a b bar plus second input. This is an OR gate, so plus symbol becomes second input is nothing but this a b bar b. Now we have seen a couple of slides back that b bar b will be 0, so this term gets dropped. So the final answer would be q equal to a times b bar. Straightforward. Now let's go to the fourth term now. And now the output of this top gate, the NOT gate, will simply be a bar, because a is the input. And if you want to find the output q, this will be nothing but the first input, which is a bar. This is an OR gate plus the second input, which is nothing but b. So we found out q equal to a bar plus b. And now we can apply De Morgan's law here. So De Morgan's law goes something like this, that xy whole bar equal to x bar plus 5 bar, right? So if I replace x as a, so if I do x can be written as a, while y bar can be written as b. Now you can see this takes this form, right? A bar plus b. So this I can write then xy whole bar. So the value of x is a. Clearly see that the value of x is a. So this will come out to be a, and then this is nothing but the value of y is, so y bar is b. So if you take bar again, so y bar whole bar will be equal to b bar, and then y will come out to be simply b bar. So I'll put y value is b bar, so a b bar whole bar. So this is the value of q that I am getting, right? So now we have solved all the 4 circuits. Now let's just go back to see what are the values that we obtained. So first we obtained a b bar, then again a b bar, then a b bar, and finally a b bar whole bar. So I'll write it here. So this is a b bar, this is also a b bar, this is also a b bar, while the output here is a b bar whole bar. So you can clearly see the first three outputs are the same, while the fourth one is different. So this will be answer, because we were trying to find the the option that is the different. So fourth option is different, and that will be our answer. Thank you for listening.